Let's have a look now at when we're travelling in a given direction, or we are in a relative location sort of due north or due east of a set position. Here we have a particle that's moving along a parabolic curve, and we can see that as the object moves, it's constantly changing velocity, and we can see that by the fact that the tangential arrow in front of the particle is constantly moving. Let's say that we're interested in the point where the particle is only travelling horizontally, or as might be phrased in the question, where the particle is travelling parallel to the I direction. That's going to be just here, where the only velocity the particle has is in the I direction. It has no j velocity. The j component of this vector in orange would be 0. So if this is our given equation for finding velocity, we would just solve the fact that our j component would be equal to 0. So that's to say 0 is equal to minus 2 plus t, or in this case that t is equal to 2. Obviously, if we were looking for a particle only moving vertically or only moving parallel to the j direction, then it would be moving straight up our page, which would indicate that the I component would be 0. Let's have a look now at solving problems with location. So here we have our ship that's been given an equation for motion, and we also have the lighthouse which has been given a set position. Pretend we are interested in the time where the ship is due north of the lighthouse. Well, that would look something like this. What would the ship have in common with the lighthouse at this point? Well, its I component would be equal. The I component for the lighthouse and the I component for the ship will be the same. The j components may be different, but we know definitely that the I components will be the same. So what do I need to solve? I need to solve the fact that 9 would be equal to 1 plus 2t, or 8 would be equal to 2t, or 4 would be equal to t, and this gives me the time where the ship is due north of the lighthouse. Okay, so we could change the question slightly and think about the time where the ship is due east of the lighthouse. Again, what would that look like? It would look something like this, and again we go back to comparing what would the lighthouse and the ship have in common at this point, and obviously the j component of their position would be equal. So this time I would be solving the equation that 12 minus t is equal to 5, or that 7 is equal to t, and this gives me the time where the ship is due east of the lighthouse, because the j components are the same. The most complicated version of this question is going to be thinking about the time where the ship is due northeast or southeast or northwest or southwest of a given point. The thing to remember here is that when we are in this location, our displacement in the I direction across here must be equal to the displacement in the j direction up here. So I find the displacement between the two and set the I component and the j component to be equal to each other. So how do I find the relative displacement? Well, the relative displacement between the ship and the lighthouse is going to be found by doing ship subtract lighthouse, which will be 1 plus 2t, and 12 minus t, subtract the point 95, which gives me 2t minus 8 and 7 minus t. And as I say, this relative displacement, when one thing is northeast of the other, means that the I component and the j component must be equal. And we can see that because we know we're forming a 45-degree angle here, so we know that both of these must be equal. So I just solve the fact that 2t minus 8 will need to be equal to 7 minus t. Or that's to say that 3t would be equal to 15, or that t will be equal to 5, and at that time the ship will be northeast of the lighthouse. Right, that's it for this video. Thanks for watching.